Hello,
Hi.
everybody. Hi, everybody, and how are you today? You're very welcome back to our Highland Tech Hub CodeInverness online session for advanced scratchers. This is the 5th lesson in our series, and we hope this day finds you well. It's a bit warm and sunny outside, so we'll get you out and into the sun in just under an hour's time. If you are watching us back later, you're also very welcome, and please feel free to give us feedback. We'll be monitoring all of our channels as per usual. Today it's Aine here with you as normal, and we also have Daryl as another mentor, and he's also working the broadcast. So hi, Daryl.
Hey guys, glad you could all join us.
Do you want to give them a shout out where they can talk to us?
Yeah, so as usual, I'll be monitoring all our normal channels, so you can message us on YouTube. You can get us on Twitter at CodeInverness. You can get us on Facebook at facebook.com/CodeInverness, and you can drop us an email at codeinverness@highlandtechhub.net.
And as we go through today's session, please feel free to drop us comments. We are monitoring YouTube as we go, and we hope that you enjoy the session today. I'm just going to share my screen now. We have been working on a few different things, and I'll take you through and introduce you to what we have done already. And there we go. So you should be able to see my screen now. I don't know, Daryl, can you see my screen?
Yep, we've got your screen there.
Excellent. So apologies for that. I should have started on my first page. So this is our first page. I've already introduced myself and Daryl, and we are mentors with Highland Tech Hub. We're also STEM ambassadors. We hope that you will have a look at our gallery. We have a special gallery for this session. It's the Advanced Scratch Gallery for Highland Tech Hub. There is also another gallery, and that is Scratch for Beginners, and feel free to check that out as well. And anything you want to post up to our gallery, please feel free. We are always happy to have a look at your projects and to see what you're interested in doing. Today is the 5th session. As I said, we are going to review, first of all, what we did in the previous week, where we looked at testing and improving our code, adding sound effects and music. I had been pointing out that you always have to test your code, test your code, test your code. Then after the 3rd session, we made some changes, and we didn't actually notice, did we, Daryl, that one of the changes that we made broke something in the code. So we went back and fixed it.
That was somewhat embarrassing. We should have tested that before we went live, but
exactly. Well, we went. It shows you exactly how this process normally goes. You have to try, and then you have to test.
But it does show that even experienced programmers make mistakes.
Exactly, and everybody makes mistakes, so it's part of the learning process.
Absolutely, and that's not to be worried about.
If you don't break, you can't build. So yeah, feel free to post up your comments and put any work that you've done in the gallery. I had a look. Daryl, did you see anything in the gallery? Has anybody posted anything recently?
I haven't looked yet. I've been rather busy this morning, but let me just take a look just now and we'll see what we can see.
While Daryl is having a look at that, I will move on and look at the things that we've covered so far in our various sessions. The first week, we looked at the elements of code and of Scratch, and we looked at the notion of expected behavior, the concept of expected behavior. What do you want your code to do? What do you want to do? Then we looked at modularizing your code, pulling your code out into pieces so that you could then work on it and then add comments as well. These are all good practices. We also looked at if loops and repeating. Then the following week, we looked at broadcasting and variables, planning and improving code. We looked at testing, sound effects, and music. And we also started off on a role-playing game. Started by getting some background and a bunny to hop across. So for viewing any of those sessions, please feel free to go back to our YouTube channel and have a look at those. As you watch through what we're doing, have a think about what it is that we're doing and ask any questions as you want, as they arise. They can go into the comments on the YouTube, or I don't know, are you able to monitor, Daryl, the Twitter while we're, or
Yes,
Facebook while
absolutely. Twitter, Facebook, and YouTube are all being monitored live, so you can get us on any of those.
Great. So today's session, I have the link here on the notes. And what we're going to focus on today is on functions, especially recursive functions, and fractals. I think we'll have a look at fractals first. Daryl, have you seen fractals before? Do you know what they are?
I have, yeah. Fractals are an interesting subset of maths where there's no one edge, where it just keeps getting more and more detailed as you zoom in.
Yes, I think this is quite a famous type of fractal, and it's called, do you know what that one is called? Have you seen that one before, Daryl?
That looks very similar to the Mandelbrot set, so I'm going to guess that would be what that is.
That is what it is. So it may look like, it may not look like much, but effectively a fractal, it looks, as you zoom in or zoom out, it emerges to have the same sort of shape, whatever level you're viewing it at. So I'm just gonna, if anybody gets car sick or anything like that, look away now, because we're going to zoom in quite quickly on this Mandelbrot set. So as you can see, it takes you down, and you're supposed to be able to see the same, the closer you get, then as it changes, you see the same thing again and again and again. So that's the way that goes. But we're not actually going to be looking at that today. We're not going to be looking at that particular one. We're going to be looking at what are called Sherpinski triangles. So I don't know if you have ever heard of Sherpinski, Václav Sherpinski. Daryl?
Yes, he's a famous mathematician who did a lot on recursion and set theory.
Yes, exactly. So I found a biography for him on Maths History, St. Andrew's page. And he actually grew up in Poland. So I was looking to see, I spent quite a few years in Poland. Daryl, maybe you don't know this, I have a Polish grandmother. So I became very interested when I realized one of his students had the same surname as a friend of mine in Poland. So I thought, oh, it can't be the same person. And actually, it wasn't the same person.
Oh,
but I did get
that's
excited.
quite a coincidence, but
it did get quite exciting there for a minute. So actually, what we'll be looking at are his what are called Sherpinski triangles today. So if I make this bigger, this is an example of a project using Sherpinski triangles, and I think probably the best way to show it is if we run it through as an example, and then we can go inside. What do you think, Daryl? So I'm gonna say max 300 for what size. Normally I'd ask you at this point to give me a size, but if you went 10, nobody would be able to see anything probably as we're as we're going on that, so you wouldn't necessarily know.
Let's go
So
for
let's see what
300 then.
happens. Okay. And I think what we'll do as well, again, normally I would ask you, but I think the easiest thing is if we start with 0, so you can get an idea of what's going to happen with the recursion as well. So if we start with 0 and then we do it again, we work it up to 1, 2, 3, and so forth. You'll be able to see what happens with the recursive function. Okay, so that's very exciting. It's basically drawn with 0. It's just drawn what you can see there, Daryl. And what does that look like to you? I don't know if you can see that.
That looks like an equilateral triangle, right?
Yes, so it is an equilateral triangle, and that's going to be important later. Okay, we'll just start again, and I'll keep the size at 300. And we will go up 1. So if we go 1 level, what do you think might happen now, Daryl? Or you might know.
I think it's going to draw a subset of triangles inside the first triangle.
Yeah, so it's a fractal, so it's going to stay a triangle. But there we have 1, 2, 3, 4 triangles within the bigger triangle. And what do you notice about the triangles within the triangle?
They're all exactly the same shape as the big one.
Exactly. So I think we'd expect, as it goes up, we'd expect to see more. So if we say 300, we won't be doing this all the session, don't worry. I'll just do another one so you can see. So yes, there we go. It keeps drawing as we go around the way. So it takes longer and longer to draw, if you notice that, Daryl, as well. Obviously, drawing just the one triangle is much faster than drawing all the subset of triangles.
Yeah, I guess that's the disadvantage of drawing one at a time rather than calculating it and drawing it all at the same time.
Exactly. So what we will look at today, we only have an hour for these sessions, thereabouts. So I didn't want to try and recreate the whole thing. It's quite involved. This one, I wanted to focus just on the maths part of it and on the triangles. So I haven't tried to focus on any of the sprite, adding the sprite, or changing the size, or putting in the variables for size and levels, and then the language. But obviously all the code is there, so you can have a look at that if you want to change anything and remix that again. So I think what we might focus on first is, Daryl, looking at this, obviously we've got some things going on here. And we talked about modular code and in previous sessions. How many types of things do you think we need to be doing? Like, first of all, to draw a triangle, that's going to be the first thing that we're going to have to do. And do you think that's going to be a difficult thing to do, relatively speaking?
I think a triangle is a very simple thing to draw. You go along a set amount, you turn 60, well, in this case it's going to be more than 90 degrees, so it'll be 120 degrees. And then you go the same amount and turn 120 degrees and go the same amount again, and there's your triangle.
Exactly. So since they're the same length, it's a pretty straightforward thing to draw. So we'll just define that there. So you were saying that we have to do the same thing how many times?
3 times. Move, turn,
Yeah.
move, turn, move, turn.
Okay. No, we don't want to repeat until. So instead of repeat 10, we'll do repeat 3. And we are going to have to move as well. So we actually have a variable that's already created, which is called side length. Where is it in my book? Oh, and I've lost my guy. So I'll just pull him out from there because he seems to be hiding somewhere. So we need our side length because we have to draw how far we're going to go. And if I go to motion, if I do move, we want to move for that number of steps, don't we? Okay. And then you said, Daryl, as well, we need to do something else.
So because a triangle has 60-degree angles, we're actually needing to go a full 120 degrees because we're not going into the triangle, we're going out of the triangle. So we need to go all the way back round.
Exactly. So it's going to be 120 degrees there. Okay. This one has also done a bit of a change. If you notice there, the color changes as we go. So we can add that just here. So we'll need to go to the pen. And you remember where we go to get the pen if we want to add the pen and it's not there initially?
That's in the extra bits at the bottom, the extensions, and then you can click pen.
Exactly. So if we change the pen color by 10, that actually gives us something. So
we want to do that there or inside the loop because it seems to change not after drawing every triangle, but after every line.
We can try it there, and we can see if we like that. And if we don't like it, we can move it there and see what that does. But unfortunately, I think because we haven't told it something else, it won't really work very well, I don't think. We need to tell it, I think, where to draw the triangle, don't we?
Yes.
Yeah, so once we tell it where to draw the triangle, so I've set up a space to show where we can draw the triangle. And that's not going to be, I don't think, too difficult in some senses, but in another, it's going to be more difficult, isn't it?
Yes, I mean, that could be quite an awkward thing to get right, depending on what your side length is.
Yes, exactly. And also, if you wanted to kind of draw in the center of the drawing, if you want to tell it where you want to go. So actually here I have a variable centered x and another one centered y. Yeah. So I'm going to set, I will just pull that across, centered x and centered, I'm going to have to set centered y as well. One is centered x and one is centered y. Okay. So here we want it to be in the middle of the canvas, don't we, Daryl?
Yes. So certainly to begin with, you want it to start in the middle.
Yeah. Yeah. So, and if we remember our, I should have left up my coordinates. We can start in the middle, and that's what coordinates, Daryl?
Very center of the canvas is 0, 0.
Exactly. So if we're going to center it, we're going to need half of the triangle on the positive side and half of the triangle on the negative side, aren't we?
Yes.
Yeah, does that make sense? So that's setting centered x to a simple number is not really going to work, unfortunately, is it?
That's a shame. That would have been nice and easy.
That would have been nice and easy. So because it's going to be one half on one side, one half on the other, what do you think we should use in terms of an operator to help us relate the side length to where it's going to go?
I think you could use a divisor.
Yeah, exactly. Okay. So if we're going to be starting on the negative side, we're going to have to start. This is going to be a bit interesting. We're going to want to do, we're going to have to do something to get it to start on the negative side. So we've already said that we want 2 here, because we want half of it on the negative side.
Take something away as well.
Exactly. So if we put in there, oops. I'm always a bit butterfingers with my, oh. I find these hard to pick up, sorry. Okay, so to get it to negative, we can start, where do you think we should start then?
So we're going to want to start at 0 minus.
Exactly.
And I think you've got your minus inside the divisor. I think you actually need it the other way around.
Oh, I might do. Yes, you're right. I've got it the wrong way around. Well spotted.
Feel free to point out in the comments if you can think what that would do and why that would make a difference.
That would make a huge difference. Oh, wouldn't it just? So 0 minus, oh, so I need to have, sorry, put that there. And then this, go there. So it's going to be 0. Finally, we get there. And it's going to be 2. Now, what do we want to put where I have a 0 here?
It's going to have to be something to do with the side length. So I wonder if it's just going to be the side length directly.
Actually, I think that is correct. We will see. Okay, now this is going to be more exciting. Setting y is going to be a little bit more involved than that was, and we're going to have to put things as well into, we're going to have to build it up in a similar way. Okay, so if we go back to the triangles here, if I'm setting x, we have a side of the triangle is the same as the length of the side. So your x is going to be the same as the side here. Well, 1/2 of it. Is our y going to be the same as 1/2 y then?
Well, it's probably not, because it's a triangle, isn't it? So triangles do all sorts of strange things when you're trying to calculate where they need to be.
Exactly. So if you can imagine a line drawing through the center there, what do you think is going to be kind of the relationship between those? So if we cut this triangle in half, what do we have on either side?
Smaller triangles.
Exactly. So we have another triangle that's 1/2 the size. So we know that this is going to be, let's say, if the side of our triangle is going to be, say, 2. Yeah. Half of it is then going to be 1. So what's your intuition, Daryl? What is your y size going to be? Is it going to be the same as 1?
No, it can't be, because it's at an angle. So it's not actually too tall. If it was too tall, it'd be off the top of the screen.
Exactly. Exactly.
Excuse the bad joke there.
It's going to be it's going to be something between 1 and 2, isn't it?
Yeah.
Yeah. And we have a theorem for that that can help us calculate it, don't we?
Yes, that was. It's been around for a long time. Pythagorean theorem.
Yes. Do you know what country? It doesn't come from the country of Poland, that theorem.
Is that not a Polish one? I think that's actually a Greek one, isn't it?
Yes, yes. Well, I think the Greeks and the Arabs were the best ancient mathematicians, And we know it for sure from the Greeks, but it's quite possible that other people in the Arab world also found quite a lot of these. And it may be that some of the Greeks took credit for things that were for ideas that were already circulating. There are also some very good ancient mathematicians from India as well, aren't there? I don't know if
Yes,
you're.
certainly in maths history, there's been great mathematicians all over the world. It's some very interesting history if you go back into it.
Mm, exactly. So even our word algebra that comes from Arabic, doesn't it?
Does, yes. There's a lot of words to do with maths that come from either Arabic or Greek or,
Mm,
to a lesser extent, Latin roots as well.
mm. And the Latin, the Romans, they were quite good uh, engineers and builders, not unlike yourself, Daryl.
I'm flattered.
Uh, okay, so if we say that the bottom is 1 and the side is 2, C is 2, and A is going to be, well, this isn't a very good example for
Might
it,
want to
but this
think of A
one,
as 1 and C as 2.
yes. So if we have A is 1 and C is 2, and we say A squared plus B squared equals C squared, so C is equal to,
C is 2,
we know C is 2,
so
and we know
A
A
is
is
1.
1. So B is going to be A squared, or sorry, it's going to be C squared minus A squared, isn't it? And unfortunately, I haven't done out the maths, so you can see that, but what actually comes out is it's the square root of 3 over 2 is the um, way to work that out. When you've actually done subtracting and taken the square root back of b, that will give you the square root of 3 over 2. But please feel free to work that out yourselves, and I'll show you as well a maths and geometry tool at the end today, where you can do some drawing if you're quite interested in the maths side of things, where you can try drawing those things out as well. So if we go to that, then the square root of 3 over 2, we have a look here for our operators. Which operator do you think we should use to show the square root of 3 over 2? Because we'll need more than one, won't we?
Yeah. So 3 over 2 is going to be a division.
Yep. And
And
if we need the square root of 3?
I think at the very bottom, there's one that does different things. And I think one of them is SQRT square root.
Exactly. So you can see here. And yes, if you want to do more things that have to do with maths, you can do them, you can try them out here. So we said the square root of 3, and that's going to be over 2. Okay, so that's our first bit done. I'm going to try not to put that in just yet because I'm going to have to build it up again. So we also want that to be a like we don't actually know, and we don't actually know what the side length is. So we can't say it's going to be the square root of 3 over 2. We're going to have to do something with that, aren't we?
Yeah, so we're going to need to do some maths with the side length to work out what that 3
Exactly.
needs to be.
Okay. And which of the operators do you think would help us with that?
So the blank times blank is the way to do a square.
Okay, so if I get our side length, and we pull that here. Then we can put all of this. Hopefully I won't break it all apart again. There we go. Oh, it's a miracle. Okay, and again, we want to center it on the page. So similar to what we did for centered X, what are we going to have to do then?
We need to do 0 minus all that huge, work.
Exactly. So first of all, I'm going to have to get the side length over 2. So I'm going to go back and get my... This is all very exciting if you're...
That's your big function that you need to put in there.
Oh, goodness. And here's me going wrong. I knew it was too good to last. Yes. So I think we put this here, don't we? We put all of this in here.
That in the first one, yeah.
There we go. Yep. Apologies, all. I'm butterfingers today.
Okay,
Oh,
if you just
goodness.
pull that out of that divisor. Okay.
Sorry. I'm going to start again. Now. Here we go. Yes, I think that's right, isn't it? Check my maths there.
Yeah, that looks right to me.
Daryl, if you can see it. Okay, and we just need one more then. So we are going to put this into the... Oh. Yes, I think that's it. Okay.
Scratch is quite good for building up blocks like this.
It is. I find it very fiddly, though.
It can be a bit fiddly, yes. But it's very easy to see where your maths has come from.
Yes, okay. And I suppose it's not too bad for sort of cleaning things up if you've gone wrong. Okay, so the last step really is then to tell our Sherpinski beetle to go to the places that we've told them to go. So if we go up to our motion blocks, continue. And if we tell it to go to centered X, centered X, and centered Y. There we go. Okay, so we can maybe try that and see what if it'll do anything just at the moment for us. See if it'll let us do anything, and see how that looks as well. If it will let us draw anything. What do you say, Daryl?
Yeah, we can give that a go. See what.
Okay, so we'll see. So we'll keep it at 300. I'll just make it bigger as well. Keep it at 300, and we'll just try a 0. See if that does it. Oh, nope. We're going to have to do a few more things before we can see.
Damn, I thought we'd crack that.
Okay, we did get him to go to the right spot. We did get him. Okay, right. So we're going to have to tell him to start walking, though, aren't we? That's what we haven't done.
Ah, of course. We've not actually told them to do anything.
Yeah. Okay, so we have another space for a block that will tell him what to do. Okay, so if you remember, we have to start with the levels because we want to know how many to draw, don't we? So, and if we have more than one, or if we have one or more levels, do we have recursion? So are we going to be drawing triangles within triangles?
Certainly could be, yeah.
Mm. And if we only have one triangle, are we going to have any triangle within a triangle?
Oh, that's a tough one. If you've only got one triangle, I'm going to say no. The first triangle is going to just be just a triangle.
Exactly. So that's going to bring us then to a different type of loop than we've used before, isn't it?
Absolutely.
We're going to need an if-else, because we've used an if loop and we've used a repeat loop, but we haven't used an if-else. So that's going to be very helpful. So what we want to say is then if, and if we go down to our operators, we want to make the first one, we're going to want to make it equal to 0. So if we have the level of recursions, I don't think we'll need 50. We can start with 0. Then we wanted to do something. And if we have any other level of recursions, then we wanted to do something else, yeah? Okay, so we want to go down to my block. And we want to pull in our triangle. And we want the triangle to do, sorry, wrong one. We want the triangle to do the side length. Okay, so I think maybe now if we do that, that can potentially do something. Or what do you think, Daryl?
I think that will do something only if we've got a level of recursion 0. So, but let's test that first, and let's test level of recursion 1 as well, just to prove that theory.
Okay.
And prove we know how the code doesn't work.
Okay, so we'll try there. So we'll try with 0. Hey. Excellent. Excellent, that worked. Now, if we try with, as you say, level 1. Do level 1.
Shouldn't do anything if we're right. And it doesn't.
And it doesn't. So thank you, Mr. Sherpinski beetle. Okay, so I think what we're going to need to do, we needed to draw, we know 3 times, yeah? So the way that we get it to do that is to repeat. Repeat. So, and we're going to be doing repeat 3. We repeat it in 3s because that's our triangle. That should give us our triangle. We've been calling this recursions. I don't know, do you have an easier way to explain that than recursions, Daryl? Because that's quite an advanced term that probably most people haven't come across before.
Recursion is when you've got one thing doing itself. So, for example, this, when it's drawing a triangle, is drawing smaller triangles. So it's the same thing that draws the triangles is also drawing the smaller triangles. It's
exactly.
quite a difficult thing to explain without using the word recursion.
Yes, so you're repeating, but at a smaller level.
Yes.
Or at a bigger level, I suppose. I don't know if that's valid to say. You're repeating the same thing, but
level.
Yeah, at a different level. That might be better. Okay, so we want to tell it to how many recursions it's doing. So if we go to Sherpinski, that's what we're defining here. So we want to do recursions. So instead of one, we can use what we. I should have explained this before we started. So we're doing something with the side length, and we're doing something with the level of recursions. Because remember, we want.
Maybe explain where they come from to begin with.
Yes. So we are going to have a different side length, aren't we, for each of the smaller and smaller, triangles. And remember, we're not starting then from 0, are we?
Oh.
Yeah. So we can't use this code that we started with for the main triangle, because that will start us off, and that will help us draw a main triangle, but that won't. Or sorry, this one. It won't. That will help us draw the first triangle, but it won't help us find the side length so easily for the triangles within the triangles.
Absolutely, and so it's worth pointing out when you define a function like where we've defined Sherpinski there, those variables are only valid for inside the function. So they've actually come from outside variables in this case, size and levels, which you can see over on the left-hand side there when we're setting up when we're calling the function for the first time. So it's worth pointing out those variables are only variables inside of Sherpinski. They're not variables outside of it. So you can't use that level of recursion somewhere else.
Exactly. And you use variables all the time, don't you, in coding generally?
Absolutely, variables are vital for coding. It'd be almost impossible to get anything done without them. But it's important to remember when you've got global variables, things like size and levels that can affect everything, and local variables such as side length and level of recursion, which is only inside one function.
Exactly. So we were interested in the side length, but it's not the full side length, are we? So we need to help it with as we did before, it's going to be the side length by 2. And the level of recursions, it's not going to be 1. If you're starting off, Daryl, and first you do, let's say we have the level. If I go back to the original one, when
your level's going to get smaller.
Exactly. Yeah. So we started off with one triangle, but then as we go, actually we can start 3. Yeah, that goes. So it's three levels of recursion. So we're going to go, we draw first the big triangle, then we need to draw the inner triangles, then that one has to get broken down and that one has to get broken down. So fortunately, there's an elegant way to do that here. So we have our level of recursions. And is there a way that we can work with that and the operators, Daryl, do you think?
I think to make it one smaller, I think you just do level of recursions -1.
Lo and behold, Daryl has got it in 1. So don't worry if it took me a while if it takes you a while to figure some of these things out, it would take me as well. So not everybody can be Daryl. And I try and put that into the correct one and not kick myself out.
The advantage of having programmed this before, but in a different language. So
that helps. Would you have done this as kind of part of learning to code, or?
Yeah. So this was
okay.
I've done this in Python as quite a common example of recursion.
Okay.
It's a very good one because makes you think about your maths as well as your actual functions. So Python has
Exactly.
a thing called Turtle,
Okay.
which is a way of drawing line graphics on the screen, similar to what your Beetle's doing.
Mm.
Um, so
Yes, that's right. I remember that. Yes. Um, that's true. So there are, and I suppose it's important to say that if you are interested in maths, there you can become a coder, and also if you're not that interested in maths, you can still become a coder because there'd be quite a few things that you can do without a very deep understanding or interest in maths.
I mean,
But
programming's encompasses everything from front end design, where you're working effectively as a graphic designer, designing how things look and feel, all the way to the real hardcore maths, where you're working on research programs to analyze data and really do some number crunching on it.
exactly, exactly. It does help you immensely, though, to review your maths. If you are interested in coding, it will help you solve some problems as well. Much more, um, it'll be much more straightforward for you to think these things through. Um, Many people say I'm never going to use maths again, but if you are going to be picking up coding, there will be things that you need maths for. So don't feel too bad if you have to, if you're not really that interested in it. It will help you a lot. So keep going that. Now we're going to also have to tell it to move, aren't we, Daryl?
Yeah.
And should we move 10 steps, or what would be a good?
Number of steps we're going to need to move is based on the side length.
Exactly.
Um,
Exactly. And we have to tell it to turn again as well, don't we? Will that change for the recursion?
the turning will um, always be 120 degrees because we're working with triangles.
Yes, that's great. Okay, so we'll just see, does that now work for us? Aha. Fingers crossed, eh? Okay, so we'll leave her at 300. We've tried already with 0. We'll try with 1 first, and then we can try with a bigger number. There we go. So that did it. Right, so putting the color in where we put it is fine. It looks like it's changing color just fine. But if you, there may be a choice with where you want to put that color change. We'll try again. How big would you like to go this time, Daryl?
Let's go for a size of 300 because that gives a nice size. Let's go let's say 4 or 5 levels deep. Let's say 5 levels deep.
Okay, say
Just to
5, and
show
let's see.
how it looks as it's processing.
Yes, there you go. Is a very busy beetle at the moment. So it's a good thing you didn't go for 6, Daryl, or we'd be here
I would
until
have been
next week.
here all day.
Exactly. Exactly. So that's another thing to notice. If you code your functions well, it will generally save time on processing. And if you code them not so well, what happens? What can happen, Daryl?
You can get programs that take forever to run. So,
Yeah, and that's why it's a good idea to review your maths when you're doing
I've
doing
seen
programming.
a simple change in a function decrease the speed a program takes the program something by 100 times. It takes 1/100th of the time to do it just because the function was written better the second time round.
Exactly.
So it can be
Exactly.
a colossal difference.
And I suppose when people are learning to code, it doesn't really make much difference how long things take because you can leave them
Absolutely, and
running or
optimization is always something that can come later. Um, I always think it's better to get something that works and then to fine tune it from there.
exactly. So you can prototype things, but just be mindful that as you go, you might want to improve the way the code functions. Okay, would you like to try and mess around with anything now that we're in and we have something that's working?
What
Would you
happens
like
if
to
we
try and change anything?
what happens if we try putting the pen where you wanted to put it and take it out there?
Oh, I was going to put it just underneath
Just
there.
put it out there.
Just run that again. I'll just do 3 levels. We'll see how we
Guys,
go. Oh, sorry.
we're going to have a very
I'm
small.
going to start that again. We won't be able to see anything.
It's maybe worth showing that size does change as well, because we've always done 300. So
Yes. Sorry, I'll go back. What size would you like to try?
let's try say 50. Something
50. Okay.
should be quite small.
And it would be. It will be. Okay, so 50, and if we say 3 levels, we can see what it's doing. There we go. Yes. So it does change the size. If we change that would have been something to test. I don't know how well you can see that actually at home on this.
It looks okay on my monitor, so
Okay.
I'm hoping everyone else sees it okay.
Okay. Might be time now, Daryl, to see if anybody has gotten in contact or has some feedback for us. I should have stopped midway and.
To be honest, I'm not seeing anything so far, but
Okay.
maybe people are just being shy.
Maybe. Okay. Do you want to try? I think we have about 10 minutes left, so we can go back and try.
And I think it might be interesting to move that pen around into different functions and see what happens. So you've got your change color in the draw triangle function. What happens if you take it out of there and put it in the Sherpinski function and have it only change pen every time it goes down a level?
Okay, so if we are going to put that into the repeat function, is that where you think you put?
Yeah, I think it might produce an interesting effect.
Okay, I will try that and see.
Julie's saying great lesson, thank you.
Oh, very good. I'll go back up to 300 just for the ease of viewing. I'll try 3 levels again. I don't know if that makes a difference, does it?
Oh, and that's certainly not what I was expecting to happen.
Okay. What if we put it after the repeat?
Try that.
We'll try the same one, 303.
So that's what I was expecting.
Right. Yes. So it's changing more gradually because it has to get all the way out of the
cluster of triangles should be the same color.
Yeah.
So you can see when it drew various bits.
Yeah. There you go. So sometimes your intuition is right. Sometimes it's not quite there. My intuition is usually not quite there. So I have to try quite a few things. So that's part of.
Other thing I was going to say is if this was me and I was testing stuff, I would remove the questioning the user as to how many they wanted to put in, and maybe set some default values like 303.
Okay.
And then re-add the defaults, re-add the questions when I was done.
Yes.
Just to avoid having to put in the questions every time. If you're iterating through a bunch of tests, it can be quite tedious to have to put in the input every time.
Exactly. Yeah. So we could have pulled all that out. We could have just pulled out that else.
Yeah. Or
and set the levels to 300. Sorry?
So I would have probably done it as I've had 2 copies of it, one called function live and one called function test, for example,
Mm,
and then just swapped in the function block.
very good. That's a good
Make it
tip.
make it very quick for testing and iterating through.
Okay, well, I'll just go back to my presentation because I think we're basically drawing down now, Daryl, to the end.
Only have
Oh,
5 minutes left, so.
one thing I did want to show everybody, if you haven't seen this, is Geogebra. And this is quite an interesting tool where you can draw, you can do graphing, geometry, you can do, no, you can do drawing. You can draw whatever you like, and you can test out a few things. So if you are interested in that, we'll have the link in the notes. You can work with probability in spreadsheets. You can also do 3D graphics. So have a play around with that if you're interested. If you'd like to give us feedback on the class, on the session, you can go to straw poll. I think Daryl will probably have that up in the notes.
I will do just as soon as this ends.
And it would be great to see you remix the project or create your own. I'll be adding it to our gallery after this session. And please share it on our gallery. So the summary for today was we looked at functions, specifically recursive functions. We also did an if-else loop, which we hadn't done before. And we looked at fractals. So actually, I lie there when I say we will look at your project specifically next week, because Daryl, what we're going to be doing is changing things up, aren't we?
Yeah, so we're going to move to some shorter videos that aren't going to be live streamed. We will still look at your project, so please send them in, but it'll be when the next video goes up. We'll do a little session before each one or before every now and again. So
Yeah,
do send them in. We will look at them, and we do look at everyone that gets sent in.
exactly. We create an RPG. We were talking about that last week. We started trying a few different things. So one of the things that I thought we'd start out with is we can maybe think about the story or the graphics that we might use. And I'm just going to be looking at doing those in little bites and putting those up gradually on the YouTube channel.
Absolutely, and these will all be influenced by yourself. So the more you send us, the more influence you get.
Exactly. So, and if any of you did the moon hack, we'd love to hear your feedback from that. But otherwise, yes, and again, here I lie. We're not back next Saturday at 2 p.m., but please monitor the YouTube channel for us. And I will stop sharing my screen. Do you have any last words, Daryl, for us?
Well, I think it is great to see everyone, and I hope we get plenty of interesting submissions about either Sherpinski triangles or other recursion, or even anything else you've been working on that you want to share. It doesn't have to be Scratch. If you're working on anything else, you can send it to the email, and we'll take a look at it, and we'll get back to you on that,
Exactly.
and we'll maybe even try and do a highlight of all the best ones at some point.
That would be great to add people's projects into our YouTube videos and in the work that we're doing with you. So it looks like hopefully the summer is with us, and we'll take a break from live sessions for just now. But we will be back at some point, and we will be posting recorded sessions up gradually as we go. Daryl, do you have any final words for everyone today?
Oh, that's all from me. Stay in touch, enjoy the summer, and we'll be back with some recorded sessions shortly.
Yeah, and that's a big thanks from myself and Daryl and everybody at Highland Tech Hub. So we will see you soon.
Okay, that's the